All right, we're going to start off first of all, just a little warm-up problem. So I want you to read this question and answer it. It says, which costs more per pound according to the graph, peas or cabbage? And don't just give me a one-word answer, but I also want you to explain how you know which one it is. So use just a few seconds to do that, and then we're going to go over it. You can just add that to your previous bell work. Very good. Very good. Now, I see several different answers, but that's okay, because I want you to be able to explain why you said what you said. How many think it's the cabbage that costs more per pound? It's okay. Don't change your answers. It's okay. And why did you say that, Parker? Why did you say that you thought the cabbage was more per pound?
Because it's sloped more towards the cabbage than the peas on pounds.
So it sloped more towards the pounds is why you said that? Okay. Someone that said that the peas cost more. Tran, why did you say the peas cost more?
I said the peas cost more because no matter where you are on the graph, the slope is higher on the cost range.
Okay, what do you mean by the slope? The slope is higher.
How diagonal the line is, because if you go to the very tip, the peas slope is higher than the cabbages.
Okay. It is the peas. It is the peas. Because here, what axis is this? The x-axis. So the x-axis is talking about pounds. As pound is increasing, what's happening to the cost? It's also increasing on both of these, which means if the pounds and the cost for the cabbage is here at that same poundage, the cost for the peas is what?
Higher.
It's going to be higher. Okay. Everybody understand that? Okay. Yesterday we talked about graphing linear equations. Who can remember what were some of the ways that we can use graphing linear equations? What did we do? We just started graphing? What did we do to graph linear equations? Ryan, what did we do to graph linear equations?
We use some tables.
Okay, we used tables, function tables. What else could we use on that?
We used ordered pairs.
Ordered pairs. What does the ordered pairs tell us, Bailey?
It tells us, the number of the x, what number it's going to be on the x and y axis.
The x and the y axis, very good. So we used the ordered pairs from the tables to graph that. What else did we talk about?
Fractions.
Fractions, okay. Did we use fractions to graph, though? What did we talk about with the fractions?
They were slope. Slope is a fraction.
Slope can be used as a fraction. Why can it be used as a fraction?
Because slope is a number over a number, and so it's rise over run.
Okay, so it's a ratio, which is a fraction. Okay, very good. So today we're going to elaborate on that a little bit more, and we're actually going to use a task to investigate rate of change in slope. So we're going to take it just a little bit further, and we're actually going to use triangles, similar triangles. What do I mean by similar? What do I mean by similar? Tria?
They're proportional.
They're proportional. What does proportional mean?
That if you enlarged it, it would be the same as the other triangle. If you shrank it, it'd be the same as the other side.
Okay, very good explanation. So we're going to see why similar triangles is going to help us explain why slope is the same between any two distinct points on a non-vertical line. Show me with your hands, what does vertical look like? What does vertical look like? Show me with your arms. Is it like this or is it like this? What's vertical? So it's straight up and down. So anything that's non-vertical, which means it's not going to be straight up and down, we can see how the distance between any 2 points on that non-vertical line is going to be the same. Then from that, we're going to derive the equation y equals mx for a line that goes through the origin. Who can tell me where the origin is? Where's the origin? Taylor, where's the origin?
Right where the x and y axis meet. Right in the middle.
So that ordered pair is going to be what?
0, 0.
0, 0. Very good. So at the origin, it's just going to be y equals mx. And for a line that's not through the origin, it's going to be y equals mx plus b. So you're going to take this information that's in the graph, just whatever you gather from it, and you're going to answer the first few questions. All I want you to do right now in your private think time, I want you to actually just work on or answer letters A through D. So right now, in this first few minutes, you're just doing letters A through D. But when you finish with A through D, go ahead and just to yourselves read the other few questions just so that you already have an idea of what we're going to work on as a group. So, but for the first 5 minutes, just doing A through D right now. You know what you're doing? What does it mean by what?
Unit rate.
Unit rate. If I say that, if I find the rate of something and I want to know what the unit cost is, how many am I trying to figure out? For how many?
For per pound.
Per pound or per item, exactly. So unit just means one, exactly. Okay, if you think it's that much, what makes you from the graph figure that? Because you said you think it's that much per CD. What from that gives you, what information from the graph makes you think that it's $15 per CD? So explain that. Yes, the cost on the left side, that is in dollar amounts. So the cost is in dollars. And that's on your y-axis. Lauren, you have about 1 minute and 20 seconds just on your personal thing. If you have any questions or stuck on something, I'll be happy to help you.
Yeah, I don't understand the unit rate.
Okay. Let's say that I were buying some apples and I wanted to know how much it is per pound.
Okay.
That's a unit rate. So what am I trying to find out? How much it is for how many pounds?
1 pound.
For 1 pound. So if I'm trying to find the unit rate of CDs, I'm trying to find out how much it is for how many CDs?
1.
For one, exactly.
Oh, okay.
But how can you derive that or come up with that based on this table?
About where the points are.
Okay. You're on the right track. Mm-hmm. Because, for instance, if I look at this graph, how much is 4 CDs?
60.
Okay, 60. How much is 6 CDs?
90.
How'd you know that? Because there's not a 90 on here.
Because it was in between 80 and 100.
Okay, so you went from 60, then to 75, and then 90. So how did you come up with that? You looked at the chart, but what's happening each time?
It's going up by 18.
Okay. All right, now what I want you to do, because I'm seeing some really good information on there, and there are a few questions, and that's okay. Y'all are on the right track, though. What I want you to do in your small groups, first of all, discuss A through D that you just did on your own, just to make sure that y'all are all on the right track. If someone found it a different way, does that mean that they're wrong? No, not necessarily. So just kind of come up or discuss what your different findings were and see if y'all still came up with the same solution with the same answers. But then I want you to go ahead and take it a little further and look at the next several questions on that same sheet, okay?